Welcome to Trimester 2, Day 7 of Calculus. Let's get to reviewing. In this first question, it's asking where f of x is both increasing and concave up, and we know it's going to be increasing when f prime of x is positive and concave up when f double prime of x is positive. So first, let's find the derivative. We will need to use the product rule because we are multiplying two things together here. So that's going to be the derivative of the first, 4x minus 3, times the second, plus the first times the derivative of the second. In this case, the second function is e to the x, and the derivative of e to the x is e to the x. We want to know where that's positive, so as we've done many times before, we're going to find out where it's equal to 0. So we set the whole thing equal to 0, and then we look, can we factor anything out? And we can. We can factor out the e to the x, and we end up with. And then we clean up the middle part. We clean up the middle part, which is a quadratic. Sorry, that's a square right there. So let's clean up the middle. So 4x minus 3x is x. We have the 2x squared. Let's actually start right there. So put the 2x squared first. So we get that. And then we have 4x minus 3x is going to be x. And then we have negative 3, and negative 2 is minus 5. So we have this e to the x times a quadratic equals 0. So now we want to know when this is equal to 0. Well, this is never equal to 0. E to the x is always positive. So we're now going to solve 2x squared minus x minus 5 is equal to 0. And that's a quadratic, and you want it to be nicely factorable. Oh, and as you might have just noticed, this should be a plus x, and that should be a plus x right there because it was 4x minus 3x. It's positive x. Whoops. So it turns out it's not nicely factorable, so you have to use the quadratic equation, and you get these two values, x equals 1.35 or negative 1.85. And then you're doing a sign diagram for the first derivative. And you really can just look at this because this is always going to be positive. So it's actually going to be positive here, and negative here, and positive here. So what does that tell us? Well, we can answer the first question here, which is where is it increasing? It's increasing when x goes from negative infinity to negative 1.85. That's this section right there. And then it's also increasing there. So union 1.35 to infinity. So that's the first half. We figured out where it's increasing. Now we need to find out where it's concave up, which involves using the second derivative. And all I've done here is I've copied over the first derivative. Now we need to use the product rule to find the second derivative. And when we do that, the derivative of the first is still e to the x. And then times the second plus the first times the derivative of the second, which is going to be 4x plus 1. We're going to do the same thing we did before and search where it's positive, so we set it equal to 0, and again, we can factor out e to the x, and when we factor out e to the x, we end up with e to the x times a quadratic, and let's clean this up, and we end up with 2x squared plus 5x minus 4, and we want that to be nicely factorable. It is not, so you're going to need to use the quadratic formula, and when you do, you get, and you use the quadratic equation to get these two decimals right here, and now we need to know where is the second derivative positive. We really only need to look at this because e to the x is always positive. And if you do, it ends up being positive here, negative here, and positive here. You can use your calculator to test that. So that means it's concave up from negative infinity all the way to negative 3.137 and from 0.637 to infinity. Now you need to look at where both of these things are true. Where are both of these things true? So you have this set and this set. So where are they both true? All I did there was I took this and put it right there. So where are they both positive? Here and here. So that one is going to be negative infinity all the way to negative 3.137 union this one, which is everything greater than 1.35. So 1.35 union with infinity. So this is where it's both increasing and concave up. Increasing and concave up. So now let's find a tangent line equation. So again, you know after many times you need a point and a slope. Let's find the point. And that's going to be f of 1 because we have x is 1. It's going to be 1 plus 5 over 2 times 1 minus 1. So that's going to be 6 over 2 minus 1. 6 over 1 is 6. So the point, oh, not the slope, the point is going to be 1 comma 6. So now all we need to do is find the slope. And to find the slope, we need to use the quotient rule. The low function is 2x minus 1, and the high function is x plus 5. So f prime of x is going to be low times the derivative of the high, which is just 1, minus high d low all over low squared. You don't need to simplify this because all you're doing right now is you want to know what the slope is when you plug in 1. So plug in 1. 2 times 1 minus 1. I'm not going to write them 1. 1 plus 5 times 2 all over 2 times 1 minus 1 squared. So what do you end up with? You end up with 1 minus, let's see, 6 times 2 is 12, all over 1 squared is 1, so it's going to be negative 11. So we have a slope of negative 11. So what's our equation going to be? Y minus 6 equals negative 11 times x minus 1. And you don't have to go any further. You can stop right there. So let's find another equation of a tangent line. And in this case, f of x is the product of two things. But sometimes you can make it look nicer if you actually multiply it out. So again, though, we need a point and a slope. But let's see what happens when we multiply it out first. Root x times root x is x. And then you get minus 3 root x plus 3 root x, and then minus 9. Look what cancels. You're left with x minus 9. That's really cool. So this equation is actually the same as y equals x minus 9. It's key to realize, though, that x has to be greater than or equal to 0. X can't be negative in that one. So what about at x equals 2? Well, we know the point has to be a x value of 2. So what happens when you plug 2 in right there? 2 minus 9 is negative 7. So we have 2, negative 7. What's the slope going to be? Well, y prime is just 1. A line has a constant slope, and the slope in this case is 1. So it's just 1. So it's going to be y minus negative 7 equals 1 times x minus 2, which is y plus 7 is equal to x minus 2. Exciting. That's all you need there. And also you'll notice that if you simplify this a little further, subtract 7, you get y equals x minus 9. That's going to be the same because the tangent line on a line at any point is going to be the line itself. So basically the moral of the story is this is just a fancy way to write the equation of a line x minus 9 where x is greater than or equal to 0. So now let's use the product rule. Let's use the product rule. If we did it here, you'd end up with f prime of x is equal to the derivative of the first times the second plus the first times the derivative of the second. So if we wanted to, we could simplify this and we could multiply it out. We end up with 6x squared minus 8x plus 12x minus 16 plus 3x squared plus 12x. So now let's combine like terms here. We end up with 9x squared right there and right there. So you get 24x minus 16 plus 16x, sorry, minus 16. Now another way you could have done this is you could have multiplied this out first and then done the derivative. That's fine. So if you multiply it out and do the derivative, you should end up with the exact same thing. So if you do that out first, we can write f of x is going to be equal to 3x cubed. I'm just foiling this out here. Minus 4x squared plus 12x minus 16x. And if you do the derivative, again, this is after multiplying it out, you end up with 9x squared. Combine these two and you end up with, that's 8x squared. So that's going to be minus 16 negative x minus 16. So you end up with the same thing. These are the same. So you can multiply it out first sometimes if it's going to be pretty easy. So the population of a rabbit colony increases at a rate of 10.4% per year. That's important. And the original population was 200 rabbits. Write an equation that represents the population p as a function of time t. So in this case, we're going to be using the initial population, which is 200, and it's regular exponential, so it's going to be 1 plus the rate. In this case, the rate is 10%. That's 0.104 to the t. So you can simplify that a little bit and get p equal 200 times 1.104 to the t. And now we have the ability to find the derivative by hand. That 200 is just along for the ride. So it's going to be ln of 1.104 times 1.104 to the t power. There you go. So when it says to evaluate p prime of 10, all you're doing is plugging 10 into there. So p prime of 10, when you do it out, it's going to be equal to 53.22. And the really important part is interpret your answer, being sure to use units in your answer. So the first part is that this is in 10 years. So in 10 years, what's going on? This is a derivative, so it's a rate of change. What is it a rate of change of? It's the rabbit population, which will be increasing at a rate of that answer, 53.22 rabbits per year. So then it says, how long will it take it to double? Well, if it starts at 200, and this is the equation, you want it to be, how long does it take to get to 400? That would be doubling. So in that case, it would be divided by 202 is equal to 1.104 to the t. You need to put that into log form. You can take the natural log of both sides if you want, that's fine. So you ln2 is equal to ln of 1.104 to the t. And the nice thing about logs is you can bring that t to the front. So you have ln2 equals t times ln of 1.104. So what does that mean? It means that t is equal to ln2 over ln of 1.104. And if you use your calculator, that comes out to be 7.006. So what does that tell you? It takes 7 years, a little over 7 years, to double the population. And that's kind of something to remember too. If you're growing by about 10% a year, it'll take 7 years to double. So what's the continuous rate? Well, the continuous rate is going to be when 1.104 is equal to e to the r. So that means you're going to be doing natural log of 1.104. So ln of 1.104, we've done this a bunch. That's going to equal 0.989. So what does that mean? It's going to be a continuous, zero. There's a zero in there. I missed a zero. 0.0. So that's 9.89% continuous interest. And we expect that to be lower than 10.4 because continuous interest acts more quickly than compound interest, or it's the most compound interest. So then it says, write an equation QT that represents the continuous growth. Well, the continuous growth, we now know what that's going to be. The initial is 200 still, but we now know it's e to the 0.0989 t, because this is we found out what the continuous interest rate was, and we just plug it in right there. So what's the derivative going to be? Well, again, the 200 is just along for the ride, so that's 200 times the derivative of this, and that's just going to be e to the 0.0989t times 0.0989, because that's the derivative up here. You have to use the chain rule. The chain rule kicks that out right there. You need to use the chain rule.